The question is, point A moves uniformly with velocity v so that the vector v vector is continually aimed at point B, which in turn moves rectilinearly and uniformly with velocity u less than v. At the initial moment of time, v vector is perpendicular to u vector and the points are separated by a distance L. How soon will the points converge? This problem is from Irodov 1.13. By the way, here Irodov refers this velocity as speed. I consider it as speed. Here also this velocity as speed. I mean this speed. Irodov refers to as velocity. Fine. Let's solve this question. Solution is, first of all, let's draw the diagram here. It says that point A moves uniformly with speed v. So v vector is continually aimed at B also. And B is, by the way, moving rectilinearly here on the straight line with uniform speed u. Now we say that initially E and B are separated by distance L. Here B is here and A is here. And the distance between A and B is given to be L here. And at each moment of time, A is aiming at B and B is moving with uniform speed u. And at the initial moment, V is, I mean A is aiming at B, right? So that V vector is perpendicular to U vector. And the distance between this is L. So we need to find at what time will this both of them converge. Fine. So initially, here velocity is V, and let's consider how the trajectory of A is going to look like. So in time interval dt, A will cover this much distance and B will cover this much of distance, somewhat less distance than A, this much of distance. So again, B is here, A is here, A is aiming at B, right? So again, it's gonna change its direction. So in time interval dt, A is changing its direction, but not the magnitude of velocity. Magnitude of velocity, which is speed v, is going to remain same. Again, B is here and A changes its direction here. Likewise, B is here. Again, A is changing its direction. Likewise. And so the trajectory is going to look like something like this. And it converges here at this point. So at this point, A meets B. So let's solve this problem. How we are going to solve it? We are going to use two different frames. One is number one, ground frame, as well as the frame of reference of B. Also we say B's frame. So we will use both the frame to solve this problem. Let's see. So let's say that A is here at any instant of time, and of course B is going to be here. So this is the distance between A and B at this instant of time at time t. So at this point of time, the velocity of B is u, and let's say this angle is theta. So this angle is also going to be theta. So let's say this distance is c at an instant of time. Then we can say minus dc over dt is equal to, this is v minus u cos theta. Relative velocity of approach in this line, right? The line joining these two will be negative of the rate of change of this distance, because this is the rate at which this distance is decreasing, is equal to the relative velocity along this line, which is v minus u cos theta. This is equation number one, and let's say this is equation one, and if we integrated minus dc is equal to v minus u cos theta dt. So this integral of dc, initial distance is L and final distance of between them is going to be 0, and let's say initially t is equal to 0 to capital T when both of them meet. This is what we have to found, this capital T. So further we get minus of 0 minus L is equal to v is constant coming out of integration, means integral dt is t minus u is constant integral cos theta dt 0 to capital T. So further we have L is equal to Vt minus u integral 0 to t cos theta dt. This is our first equation. Let's solve this first equation. So we have to find this theta as a function of time. It is very difficult to find it. Mathematically express theta as a function of time and then integrate it. So we are going to use this ground frame. We have used this B frame. Now we are going to use ground frame to find this equation, to find this 0 to t integral cos theta dt. Let's see how we are going to do it. See, if I consider this distance xb from ground frame, let's say an observer is here. Here is an observer sitting and observing the motion of B. Of course, xb can be written as directly u times t because u is constant. So this distance is going to be its speed times the time taken. Let's say this is equation number 2. And now if we consider the motion of A from ground frame, so if I say, let's say this is XA. XA is the coordinate of A. If an observer is here, then we can write dxa over dt, which is rate of change of the x coordinate, is going to be the component of its velocity along x axis, which is v cos theta, right? Because v cos theta is the component of velocity of A along x axis, which is v cos theta. So if we integrate it, we get dxa is equal to v cos theta dt integral. V is constant, so let it come out of integration 0 to t, and if you integrate it, initially it's 0 to, when it meets, now look at here, when it meets, so its x coordinate, the x coordinate of A is going to be xb only because both of them are meeting at the same point, and so their horizontal components like xb and xa is going to remain same. So this is equal to xb also. So we have xb is equal to v integral cos theta dt 0 to t. So we have used this ground frame to find out the equation 2, which is the distance, and also xb, I mean this for A along horizontal direction. So we have used this ground frame. So let's say this is equation number 3. Now we are going to solve equation 1, 2 and 3 to get our time. Very easily we can see that xb from equation 2 and 3 is ut. This ut is equal to v. Yeah, I have plugged the value of xb from equation 2 into equation 3 integral 0 to t cos theta dt, and also we have integral 0 to t cos theta dt is equal to ut over v. And now we have got this value 0 to t integral cos theta dt ut over v. Oops, it's ut over v. So now we are going to plug this here. In equation 1 we get L is equal to Vt minus u times ut over v, which is equal to T is equal to Lv over v square minus u square, and this is the final answer. And we can also see that v must be greater than u. That's why in the question it is given that u is less than v, otherwise time would have been negative. Fine. Thank you very much. Hope you understand it.